We're Team 502 Bad Gateway. I'm David Allen.
I'm Sam Tomlinson.
And we made the Human Contaminant Containment Unit for Intel's Cleanroom Challenge. So the issue at hand is that cleanrooms are used in semiconductor manufacturing, and special garments must be worn in order to prevent humans from shedding particles into the air and damaging the semiconductors. They must be worn for long periods of time whilst the user works on their semiconductor. And as silicon features decrease further in size, cleanrooms must be held to stricter and stricter standards in order to keep up. This equipment then must also be able to keep up with these stricter standards in order to prevent defects in the semiconductors. So our solution to this is a modular smart mask, which would allow ventilation for the user while still minimizing human contamination. It would be modular, which would allow the device to be future-proofed by just upgrading the electronics or swapping out the filter for a better one. Then the modularity would still also allow for ease of cleaning without damaging electronics. You can just remove them and then autoclave whatever else. And then the ventilation would allow the user to breathe normally and more naturally while minimizing condensation within the mask itself and goggles and minimizing overall discomfort. Then there would also be smart features, which would allow for ease of communication between colleagues, both in and out of the clean.
Our preliminary prototype was constructed with laser cut and bent acrylic. In addition to the mask, the prototype also features a microphone and speaker that are interfaced to a Bluetooth and Wi-Fi connected microcontroller. This would allow for communications between wearers. It also includes the ventilation fans on the side, and the clear face mask allows for more natural face-to-face communication. So some of the challenges we faced along the way include the 24-hour time constraint that made 3D printing an intricate model impossible. We also lacked a second microcontroller, so we could not test connectivity between masks. We also had to get creative in coming up with a proof of concept for our solution. We lacked some other materials, including a strong enough voltage supply for the fans, as well as various connectors and wires. Finally, as we progressed through the event, we brainstormed more and more ideas and features that we were unfortunately unable to implement in time.
So on the right, you can see a 3D model of the future prototype that we made in Fusion 360. It can be readily produced with injection molded parts. It would still maintain the built-in microphone and headphones, which would allow with direct communication between mask users or any other Bluetooth devices like smartphones or computers. And there would be a pump which would provide positive pressure into the mask, as well as pushing exhaust back out the back through a HEPA filter in order to allow the user to breathe normally, as well as maintain cleanliness in the clean room. There would also be rubber gaskets, which would provide higher comfort for the user and allow the mask itself to fit more onto different users.
So we really enjoyed this challenge. It let us experiment with new electronics and software, as well as letting us flex our problem-solving muscles.
Yeah, this is easily the most fun and unique challenge that we've done in the about 4 Makeathons and hackathons that we've done. And I hope that you enjoyed the device that we spent the past 24 hours making as much as we did.
Thank you.
Thank you.